Today's problem is spiral order matrix 2, not to be confused with spiral order matrix 1. Although this looks like a pretty standard spiral order matrix problem. Asked at Microsoft and Amazon. Problem description. Given an integer a, generate a square matrix filled with elements from 1 to a squared in spiral order. Return the generated square matrix. Okay, we'll look at an example of that. A is between 1 and 1,000. Input. First and only argument is an integer, a. Output. Return a 2D matrix, which consists of the elements added in spiral order. All right. Now, if you're using the Java template as we are, we're not returning a matrix, actually. We're returning a list of lists. To me, it makes more sense to do it as a matrix, but that's not what the problem requires. So, okay, example inputs 1, 2, and 5. Well, 1 and 2, yeah, are pretty simple. 5, let's look at 5. They have a drawing of it here in more detail. So a spiral matrix, you're going to start in the top left corner with the number 1, and then you're going to go horizontally to the top right corner, and then from there you're going to go vertically to the bottom right corner, and then you're going to go horizontally to the bottom left corner. Then you go vertical again as far as you can go. The top row is full now, and then again horizontal. I guess. Yeah, I mean, you could count these, but it doesn't really help in the solution. I mean, so we're going, if A is 5, we're going 5 across the top, and then we're going 4 vertical, 4 horizontal, 3 vertical, 3 horizontal, and so on until you spiral into the middle. Let's look at how we can do that. So really, even though we need to return a list of lists, it's easier to solve the problem with a matrix and then put the matrix into a list of lists rather than having a bunch of gets and adds on lists. So we'll define an integer matrix, a by a. We'll define some variables, count. Count is going to keep track of what is the next number that we're going to put in the matrix. It starts at 1 and increments for every element. Top and bottom are the indices of the top row and the bottom row. Those will change as we fill the matrix. Left and right are the indices of the leftmost and rightmost column of the matrix, and again, those will change as we go through the matrix. So while the matrix, this basically is that the matrix is not full. Top less than or equal to bottom, left less than or equal to right. While the matrix is not full, we will traverse the top row, go from left to right, and put in the numbers. I equals left. Top is 0. Yeah, and we iterate from left to right, so we fill the entire top row. And then increment the top row. The top row is full, so we move the top boundary down. Traverse down, I is going to go from top to bottom. Now we've already incremented top, so we're going to start in the first row. Right now we would be where the 6 is there. iterate from top to bottom, and the matrix will fill the right-hand column. And then decrement right. So right moves to the left because the right column is now full. Traverse to the left in the bottom row. So I is going to go from right to left, and in the bottom row, we're going to put the appropriate numbers, the count variable, which we increment for each element. Once we filled that, the bottom variable gets decremented, the bottom boundary moves up because the bottom row is now full, and finally, traverse up the left column. So we start with I at the bottom. Now the bottom boundary has been moved up, the top boundary has been moved down. So all we have left here is the 14, the 15, and the 16 in this case. And we will traverse up the left column, add the numbers, and then move the left boundary to the right. Okay. That takes care of the entire boundary of the matrix, and now we have a smaller square matrix in the middle, a 3 by 3, and we fill that the same way in the while loop until everything is done. Now the last part of this, starting on line 38, is just the creation of a list of lists and moving the numbers from the matrix into the list of lists and then returning it. All right, let's give it a try. All right. It's a common matrix problem. If you found the video helpful, go ahead and hit like, subscribe, check out the playlist on your screen. There are other videos to keep leveling up your interview skills. The video description and the pinned comment have links to more resources, including a free LeetCode patterns cheat sheet. I called it LeetCode patterns cheat sheet. I mean the patterns are the patterns are the same across all sites of this nature, and you can download that immediately. As I said, it's free, and that's it. We'll see you next time.